Hi there, this is Jim. Welcome to my YouTube channel. In this video, I explain some examples to explain more about the point-slope form of the equation of the line. Point-slope form of the line. So let me write here, point-slope form of the equation of a straight line. Okay, so here, let me illustrate the point-slope form of an equation of a line by drawing a straight line on a Cartesian plane. So let's have this as the y-axis here, and this the x-axis. Okay, let's have this as the, of course, point of origin. Now suppose we'll have this line here. Okay, there you go, and we'll have, say, this 2 points on this straight line. Let's have this as point xy. So this will be point xy, and another point, let's name it as point x1 y1. Okay, now let's draw an imaginary right triangle. Alright, so this the imaginary right triangle. Okay, this being the right angle. Okay, now let's have this angle here to be denoted by theta. Okay, clearly this opposite side of the angle theta, referring to this right triangle, is of course y minus y1. Why is that so? Of course, this distance here is y, and this smaller distance here is y1. Okay, that's why we'll have now the difference y minus y1, right? So similarly, the distance from this point to this point, which is the adjacent side of this right triangle, with reference to this angle, of course, this is now x minus x1. Okay, again, with reference to this right triangle, we can recall that the slope, which is equal to tangent theta, okay, is of course equal to the opposite side y minus y1 over the adjacent side x minus x1. This will yield the equation of the line, okay, y minus y1, which is equal to m times x minus x1. This is called the point-slope form of the equation of the line. Here, m is the slope, and of course, x1, y1 is a point on the line. x1 being the x1 being the x coordinate, and y1 being the y coordinate of that point, x1, y1. Again, the point-slope form of the equation of the line. Let's have some examples. First, a line passes through the point 3, -4. If the line has a slope of 1/2, determine the equation of the line in standard form. Okay, we'll now sketch the line on a Cartesian plane. As we can see here, this line passes through this point 3, negative 4. This point 3, negative 4 will be, of course, our x1, y1. That is the point x1, y1. Thereby, x1 will be equal to 3 and y1 is of course equal to negative 4. Okay? Now, we'll derive the equation of the line given also this slope which is equal to m, which is 1/2. Okay? Now, the point slope form of the line is given by this equation. Y minus y1 is equal to m times x minus x1. We'll now substitute the values of y1, m, and x1. Okay, so we'll have now y minus negative 4 is equal to 1/2 times x minus 3. Right? We'll simplify further and we'll have y plus 4 is equal to 1/2 times x minus 3. Okay? To simplify further, we'll now multiply the whole equation by the LCM of the fractional terms. So we'll now multiply this by 2 and we'll have 2y plus 8 is equal to x minus 3. Transposing this x term to the left side and this constant 8 to the right side, we'll now have negative x plus 2y is equal to negative 3 minus 8, which when simplified further, negative x plus 2y equals negative 11. This is now the equation of the line in standard form. Although we can still derive an equivalent equation for this by multiplying the whole equation by negative 1, we'll have x minus 2y is equal to positive 11. Okay, there you go. This is now the equation of the line in standard form, given that it passes through this point 3, negative 4, and given also that it has the slope positive 1/2. Let's have this second example. Here, we'll find the equation of the line in standard form that crosses the x-axis at the point 5, 0 and has a slope of negative 2/3. Okay, as we can see here, we have this sketch of the line passing through the point 5, 0 and has a slope of negative 2/3. Having a slope of a negative value, of course, would tell us that the line is sloping downward. Now, to find or determine the equation of the line in standard form, we'll make use of the point slope form, since we are given a point and we are given the slope. So the point slope form of the equation of a straight line is given by this equation: y minus y1 is equal to m times x minus x1. We know the slope m to be equal to negative 2/3. y1 and x1, of course, will be taken from this point 5, 0. This point 5, 0 is, of course, our point x1, y1, right? Which tells us that the value of x1 is equal to 5 and the value of y1 is equal to 0. Now, substituting these values of x1, y1, and m into this equation, we'll now have y minus 0 is equal to negative 2/3 times x minus 5. Okay? Now, to simplify further, we can multiply the whole equation by the LCM of the fractional terms, which is of course 3. So that, simplifying further, we'll now have y is equal to, 3y is equal to negative 2 times x minus 5, right? Which is, of course, 3y is equal to negative 2x plus 10. Transposing this negative 2x to the left side, we'll now have 2x plus 3y is equal to 10. There you go. This is now the equation of the line in standard form. I hope you learned something from this video. In my next lecture video, I'll be explaining more about the intercept form of the equation of the straight line. Don't forget to subscribe on my YouTube channel for you to receive instant notifications about newly uploaded lecture videos. Thanks for watching.